Good morning, friends. This is Dr. Baljeet Kaur, lecturer of chemistry at Government Polytechnic College for Girls, Patiala. I am delivering a lecture on the topic Basics of Thermodynamics. Under this topic, we will be discussing about the various contents like the definition of thermodynamics, what is the importance of thermodynamics, the system, what is a system, what are the various types of system. Then we will be discussing about extensive properties, intensive properties, the state of system, state variables, state function, what is a process. Then we will be discussing the types of process, what is internal energy and change in internal energy, then enthalpy and change in enthalpy. Then we will be discussing about entropy and change in entropy, and last of all we will be discussing about the laws of thermodynamics, that is the zeroth law, the first law, the second law and the third law of thermodynamics. So let's start with our topic. First of all, let us see what is thermodynamics. Thermodynamics is a Greek word which means flow of heat in physical and chemical reactions. So, thermodynamics basically deals with the flow of heat that is taking place in physical and chemical reactions. Or we can also say that thermodynamics is a branch of science which deals with the study of different forms of energies and their interconversions. So, we are dealing with the study of different forms of energy and their interconversion. It also deals with the energy changes that are taking place in physical and chemical processes. Then thermodynamics, what is the importance of thermodynamics? Why do we study thermodynamics? Thermodynamics is useful to predict whether any chemical reaction can occur under specified conditions. It is also used to predict the extent of chemical reaction before equilibrium is reached, or this thermodynamics is used to derive important laws like the law of equilibrium, etc. So, these are the importance of thermodynamics, that is to predict whether any chemical reaction would take place or not under a specified set of conditions. Then the extent to which a chemical reaction takes place. These are the two main things that have to be dealt with thermodynamics. Now, let us discuss the various terms that are used in thermodynamics, because before studying thermodynamics we should know the terms that are useful in thermodynamics. So, the first thing that we should know is what is a system. A system may be defined as the part of universe selected for thermodynamic consideration, that is to study the effect of temperature, pressure, etc. So, what is a system? It is a part of the universe that is selected for studying the effect of temperature and pressure. Or it may also be defined as specified part of universe in which energy changes are taking place. So, it is system is a part of the universe where energy changes are taking place. Then what is surrounding? The remaining part of the universe excluding the system is called surrounding. Everything else except for the system is known as the surrounding. So, we can say that universe, total universe is made up of system and surrounding. So, if we sum up the system and surrounding, the whole thing is the universe. So, the system and the surrounding, both of them can be separated by real and imaginary boundary. The system and surrounding can be separated by real and imaginary boundary. So, that is what is system and surrounding. So, system was part of universe that is used for studying the effect of temperature and pressure, and surrounding is the rest of the portion of universe. This is a diagrammatic representation. Over here we can see that this whole thing in the center, the shaded portion is the system and the rest of the portion is surrounding, and the system and surroundings are separated by boundary, both of them. So, this is a diagrammatic view of a system and a surroundings. Now, next thing, what are the types of system? Now, we can have various types of system. The first is open system. Now, open system is that type of a system where the mass and energy can be exchanged with the surrounding. For example, if some water is kept in an open vessel or hot tea is kept in an open cup, it is an example of an open system. This is the diagrammatic representation of an open system. Over here, we are having the exchange of mass as well as energy with the boundary. The next type of system. The next system is the closed system. In a closed system, there is only the exchange of energy with the surrounding. No exchange of mass takes place. For example, if water is placed in a closed metallic vessel or hot tea placed in a closed teapot, if you have a closed teapot and you are putting water or tea in it, that is an example of a closed system. Let us see the diagrammatic representation of a closed system. This is a diagrammatic representation. In this type of a system, there is no exchange of mass taking place with the surrounding. The system and surrounding, no mass is getting exchanged, but energy can be exchanged with the surrounding. So, such type of a system is known as a closed system. Then another type of system is the isolated system. Isolated system is that system where there is neither exchange of mass nor energy with the surrounding. For example, if water is placed in a vessel which is closed as well as insulated, or tea is placed in a thermos flask, so that is an example of an isolated system. You are placing tea in a insulated or a thermos flask, it is an example of an isolated system. See what happens over here. In such a system, we have no exchange of mass as well as no exchange of energy taking place between the system and the surrounding. So, such type of a system is known as an isolated system. So, we have three types of system as we have seen. The first is the open system where both mass and energy can be exchanged. The second is a closed system where only exchange of energy takes place with the surrounding and no mass is getting exchanged. And the third type of system is the isolated system in which neither mass nor energy is being exchanged with the surrounding. So, these are the three types of system that we have in the universe. Now, the next topic. We can classify the system on the basis of nature of constituents present. A system can be a homogeneous system or it can be a heterogeneous system. In a homogeneous system, all the constituents are present in same phase and the composition of the system is uniform throughout. All the constituents are in the same phase and the composition of the system is uniform. So, such type of a system is known as a homogeneous system. Then what is a heterogeneous system? A heterogeneous system contains two or more phases and the composition is uniform throughout, is not uniform throughout. So, such type of a system is known as an heterogeneous system. So, we have two types of system. In thermodynamics, we have homogeneous system as well as the heterogeneous system on the basis of nature of constituents. Next thing, then what is intensive property and what is extensive property? Intensive properties. These are those type of properties that do not depend on the size of the system or the quantity of matter present in it. They are dependent only on the nature of substance present in it. Such type of properties are known as intensive properties. So, intensive properties are those properties that do not depend on the size of the system or the quantity of matter present, but they are dependent only on the nature of substance present in it. And examples of intensive properties are pressure, temperature, density and surface tension. So, this is intensive property. The next type of property is extensive property. An extensive property depends on the quantity of matter present in the system. Intensive property did not depend upon the quantity of matter present, but the extensive property is that type of a property that depends on the quantity of matter present in the system. For example, volume, energy, heat capacity, entropy, all these are examples of extensive property. Here volume or energy or heat capacity, all of them will depend upon the amount of material that we are taking or the quantity of material that we are taking in the system. So, these type of properties are known as intensive properties. So, we have two types of properties we have discussed, intensive property and extensive property. Intensive property do not depend on the size of the system or quantity of matter present in it, but the extensive property depends on the size of the matter present in the system. So, this is about the intensive properties and the extensive properties. Now, let us discuss the next thing. So, till now we have studied about system surrounding the various types of system, then what are intensive properties and what are extensive properties. Now, the next thing we will discuss, what is state of a system and state variables. State of a system are the condition of system which is described in terms of certain measurable properties such as temperature, pressure and volume, etc. So, state is the condition of a system, and this condition of a system can be measured by properties such as temperature, pressure and volume. So, this is what we mean by state of system. Next is what are state variables. Then what are state variables? The properties of system such as temperature, pressure, volume, when changed, the system also changes. These properties are called state variables. So, what are state variables? State variables are the properties of system such as temperature, pressure and volume which get changed when the system also changes. They are known as state variables. So, we have seen what is state of system and what are state variables. State of system is the condition of system which is affected by measurable properties like temperature, pressure, volume, etc. And what are state variables? The properties of system like temperature, pressure, volume, etc., which change the state of a system are known as state variables. Now, next topic, what is a state function then? State function is defined as the property whose value depends only upon the state of the system and is independent of the path by which the state has been reached. So, state function is that property whose value depends only upon the state of the system and is independent of the path by which the state has been reached. For example, if a person is standing on the roof of a building, he has a fixed value of potential energy, and the potential energy of the person does not depend whether he has reached there by lift or by stairs. His energy will remain same. So, such type of a function is known as state function. So, state function is a function that does not depend upon the path by which the state has been obtained, but only depends upon the initial and the final position. That type of a function is known as a state function. The example of state functions are potential energy, pressure, volume, temperature, internal energy, etc. So, all these are state functions. Now, the next topic, what is a process? When a state of a system changes, then process is said to occur. So, what is a process? When the state of the system changes, then process occurs. And we can have the first and the last state of process. They are known as the initial and the final state respectively. The first and the last state of a process are called the initial and the final state of the system. So, process is state of system changes, then that is known as a process, and the first state is known as the initial state and the last state is known as the final state. Now, the next thing. So, we have seen what is a state of system, what is state variable, then what is a state function, and now we are discussing what is a process. And let us see, now this whole is a process. The system has started from this point, it is going like this, reach this point, then along path 2, then along 3, along path 4. So, this changes are taking place in pressure and volume. Here the pressure is decreasing, then the pressure is decreasing over here, volume is remaining constant. Here the pressure is also increasing, volume is decreasing. Here the pressure is increasing, volume is constant. So, this is a process. So, the state of the system is changing, so a process is said to take place. So, process gives us the path by which the system changes from one state to other. There are certain processes in which particular state variable is kept constant, like we had seen here. This 4 process and second process. Here one of the variable, the volume is kept constant over here. So, there can be a process in which certain state variable is kept constant. So, process only gives us the path by which the system changes. Then we are discussing about the types of process. We have various types of processes. The first type of process is known as an isothermal process. Isothermal process is defined as the process in which the temperature of the system remains constant. Iso means same, thermal means temperature. So, this is the process in which the temperature of the system remains constant. And heat can flow from system to surrounding and from surrounding to system in order to keep the temperature constant. So, what is an isothermal process? An isothermal process is that process in which the temperature of the system remains constant, and in order to keep the temperature of the system constant, there can be flow of heat from system to surrounding or from surrounding to system. This is an example of an isothermal process. Pressure is changing, volume is changing. This is the first position, this is the second position. Process is taking place, pressure is changing, volume is changing, but the temperature of the system is remaining constant. So, such type of a system is known as an isothermal process. Next type of a process is an adiabatic process. An adiabatic process is a process in which the system does not exchange heat with the surrounding and the system is completely insulated from the system. So, in an adiabatic process, there is no exchange of heat. In an isothermal process, exchange of heat was taking place, but in an adiabatic process, there is no exchange of heat and the system is completely insulated from the surrounding. Now, the next type of process. The other type of process is an isochoric process. In an isochoric process, the volume of the system remains constant during the process. There is no change in the volume of the system. Iso word is derived from the word same, choric here, it means volume. So, in an isochoric process, the volume of the system remains constant during the process. The fourth type of process is the isobaric process. Again, iso means same, baric means bar word comes, this is pressure. So, in an isobaric pressure system, the pressure of the system remains constant during the process. So, we have seen that we have 4 types of process taking place. The first type of process is known as an isothermal process where the temperature is remaining constant. The second type of process is adiabatic process. Then we have a third type of process, that is the isochoric process, and a fourth process, that is the isobaric process. So, this is about the various types of processes that are taking place in a thermodynamic system. Now, the next topic. What is a cyclic process? In a cyclic process, the system undergoes a series of changes and finally returns to its initial state. We are having various changes and at the end the system returns to its initial state. So, such a type of process is known as a cyclic process. Let us see the diagram. This is a cyclic process. We started from this point, red point, went by a path 1, path 2, path 3 and path 4, and we are returning to the initial situation. So, such type of a process is known as a cyclic process. So, a cyclic process is one in which the system undergoes a series of changes, but it returns back to its same situation, initial position. So that type of a system is known as or process is known as a cyclic process. Now let's go further. Then we can have reversible process and irreversible process. Now let's see what's a reversible process. A reversible process is a process that is carried out very slowly so that all the changes occurring in the direct process can be reversed and the system and the surrounding remain in the state of equilibrium. So, reversible process is carried out infinitesimally slowly so that all the changes occurring in the process can be reversed and the system remains in equilibrium. With the system and the surrounding there is an equilibrium. But such a type of process is an ideal process. It is only ideal and it cannot be realized in actual process. Such type of a process is known as a reversible process where we can reverse the system. The another type of process is the irreversible process. In an irreversible process, the change is brought about rapidly and the system does not attain equilibrium. And the force which drives the reactants towards the product is greater than opposing force, which is to carry the reverse process. So, such type of a process is known as irreversible process. So, we have two processes taking place, reversible process and irreversible process. In a reversible process, it is carried out very slowly so that the changes are occurring in the direct process and they can be reversed, and in an irreversible process the changes are carried out very rapidly and the system does not attain equilibrium. A reversible process, as we have seen, a reversible process attains equilibrium and an irreversible process does not attain equilibrium. So, that is the difference between a reversible process and an irreversible process. Now, the next topic, same, what is a spontaneous process? A spontaneous process may be defined as a process which can take place by itself or initiation. Now, spontaneous process which can take place by itself, we can have various types of spontaneous process like the evaporation of water in an open vessel, the dissolution of salt in water, or the flow of water down the hill. If water is flowing down the hill, it is a spontaneous process, or evaporation is taking place in an open vessel, this is a spontaneous process. So, spontaneous process is a process which takes place by itself and it can take place by initiation also, like combination of oxygen and hydrogen to form water, lighting of candle, that is also initiated by initiation. So, these are spontaneous process. The other type of process is non-spontaneous process. Non-spontaneous process is the process which cannot take place by itself or initiation. It cannot occur by itself. For example, we can see that we do not have any flow of heat from cold body to hot body. This cannot take place. This is a non-spontaneous process. Flow of water up the hill, it is a non-spontaneous process. Or dissolution of sand in water, this is also non-spontaneous. So, spontaneous process is one that occurs by itself and non-spontaneous process is one which cannot take place by itself or initiation. So, these are the differences between a spontaneous process and a non-spontaneous process. Now, the next thing. Now, there are certain thermodynamic quantities that we will be discussing. Before discussing the laws of thermodynamics, we will be discussing certain quantities. First, what is internal energy? Every system is associated with a definite amount of energy and this energy is called its internal energy. and it is denoted by letter capital E or capital U, and it depends upon the various factors such as temperature, pressure and chemical nature of the substance. So, internal energy is the energy that is associated with the system. The amount of energy which a system has is known as